right, so I believe that these are concepts that you are familiar with already from long ago in your days of algebra, but it has been a little while since you have seen it, but hopefully as I start running through this with you a little bit, you'll go, oh yeah, I remember that. So the first thing is a relation. In a relation, quite simply is a set of pairs of numbers. Okay? So, somebody raise their hand and tell me a pair of numbers. Lindsay, you can do it. A pair of numbers.
3 and 4.
3 and 4. Nice job. Okay, so there's a pair of numbers. Somebody else raise their hand. Give me another pair of numbers. Stacy?
0
and 7. Okay. I'll take 2 more. Great.
39.
Okay. 39 and 93. Why do you guys hate me? I don't know. One more.
I know, right? I got one.
Can we do like any numbers?
Any pair of numbers, yeah.
How about 300,000
Uh-huh.
and 469,700?
469,700.
Yeah.
Alright. That was my
Okay, so that is an example of a relation. Because we have a set of 4 pairs of numbers. Not so tricky, right? Right?
I don't do anything with them.
Yeah, we're not really going to do anything with them. And so that's one way that you can show a relation is by just listing them as ordered pairs. Another way that you can do it is with a mapping diagram, which sounds fancy, but it's not. And in a mapping diagram, you have your inputs and you have your output. And so for this one, I'm going to go, my inputs are 3, 0, 39, and 3 times 10 to the 6th. Tricky stuff, huh? My outputs are, anybody?
The last number.
The second numbers, yeah. 4, 7, 93, and 469,700. And then the way this works is since we're talking about it as something that's actually happening, like you're putting something in and getting something out, we draw a fun little arrow here and say the 3 goes to the 4, the 0 to the 7, the 39 to the 93, and that one to that one. And for the relation that we came up with, those arrows aren't really very interesting because they're all just going straight across. But if somebody had said, for example, 3, 6, and we wanted to add that to this thingy, we don't need to put another 3 over here because we already have a 3 in our input, right? And then we would just toss a 6 over here, and we would draw another arrow from the 3 to the 6.
Is there a 6 anywhere?
Where actually I just did a bad thing. It's supposed to be in like numerical order, but I couldn't fit it in between the 4 and the 7, so I screwed that up. But I'm a bad person. Okay, so that's another way that you can put this, show a relation. Okay, anybody think of another way that you can do it? That you've seen before in a math class? You could make a table.
Chart.
A table or like a T-chart. And usually when we make a table, we call the input values the X's, and the outputs are the Y's. And we just need to list them out basically like the mapping diagram we just did. We can't remember what our inputs were, and they're on the other page. So
3,
3,
39.
Wait, 39 and 3 to the 3x
Okay, and I'm not going to do that other one that Cody, or oh no, I guess it was the other one. And then this time, since I added that other one on there, we need to put the 3 on there again. Okay, because that came up twice. And so what were the outputs or the y values that went with them? 4.
93, 469,700.
And 6. Okay.
Wait, it's in numerical order.
Okay, now this one, can I put these in the y's in numerical order?
No.
No, because they have to match up straight across from the x's that they live with, okay? I could mess with the order in my mapping diagram because I used arrows to show who goes with what. But in a table, you assume that the one that's right next to each other go together, so they have to stay where they are, all right? And then what's the last way that you can show yeah, so you could take these and graph these, and I don't want to do that right now, because that would be a pretty tricky graph to do thanks to Cody Usher, okay? So that's all a relation is. It's a set of pairs of numbers. There's 4 different ways that you can do it. You can do it in ordered pairs. You can do it with a mapping diagram. You can do it with a table of values, or you can do it on a graph, okay? So they have an example problem that we will not go through together on page 61 because it's just the same thing all over again. When skydivers jump out of an airplane, they experience free fall. The photos show various heights of a skydiver at different times during free fall, ignoring air resistance. So you can see that at 0 seconds he starts in the plane, and how far off the ground is he? 10,000 feet. And then 4 seconds later he has fallen to 9,744 feet, and then he continues to fall 8, 12, and 16 seconds. So you can take those and you can make an input and an output mapping diagram. You can make ordered pairs, you can make a table, you can make a graph. Okay? So that's pretty straightforward. All right, what's a little, okay, then associated with these things are 2 words that you are now going to see a lot. And you're going to learn to love them. All right? The domain is a fancy name for the x values. And what do you think the range is?
Y values or output.
Or the output. Range is the y values or outputs. So from our table right there, what can you tell me the domain of that relation is? 3? What's more than just one input value? What else is there? 0. What else is there? 39.
3
And 3 times 10 to the 6th. And then we don't have to rewrite the 3. And so I would write the domain of that. Make these funny little squiggly brackets. You don't, I mean, you know, you don't have to be. I went to school for like 16 years to learn how to make them as good as that. So.
You sure?
No.
You watched
So my domain for that one was 0, 3, 39, and 3 times 10 to the 6th. I'll try and be a better teacher and list them in order this time.
Wait, did we have to put 3 and 5?
No, for the domain you don't have to put that in there twice. So the only time you have to put it in there twice is if you have the table or the ordered pairs. And then what would you say the range is? And again, I'm going to list them in numerical order.
4, 7, 6, 4, 6. Just getting tested.
7.
7, and that really big one.
Right. Okay, so that's a pretty simple idea, right? Domain is the x's, range is the y's. But don't worry, we'll take that simple idea and make it super, super confusing and complicated. Of course.
Is that the end of our lesson for today?
No, that's the end of the first part of our lesson. That's all we need to know about relations. But remember, there were two parts. What's the other part? Functions. I tell you. Okay, so then the second thing that we need to learn about, and this is a little bit more complicated, is what a function is. A function is a relation where each input has exactly one output. Yeah, mostly everything that we'll be talking about is a function. There are some things when you get into math analysis and into calculus, you're able to do math with things that are not functions, but pretty much all the things that we're going to work with are functions. And so the main reason for you to know what a function is because for the most part, when it's not a function, that means we're going to throw it out and we're not going to mess with it at all. So it's mostly for you to know whether you can even do the problem or not. Okay? So let me explain what this means. Let's go back to our mapping diagram, because that's the easiest way to see whether it's a function or not. Does each one of those input values get mapped to exactly one output value or not?
No.
No. Which one gets mapped to more than two? Three. Okay. So that's why I cheated and I added this 3, 6 on there, because that made it so that this is no longer a function, because the 3 goes to the 4 or the 3 goes to the 6. And the way I described this to you when you were in algebra a couple of years ago is as if you were driving your car. Sometimes when you put it in drive, it went forward, and sometimes it went backward. You would say that your car is not functioning, right? Okay? It's the same thing in math. Every time I put in a number, I want to get the same answer back, or else something wacky is going on, and I'm not going to be able to work with that very easily. So, -304 is my domain. My range is -217. Did you hear that fun little noise?
I didn't.
I got an email. Upgraded to the new operating system, and that's the only difference I can tell. So it's totally worth it. I have a cloud though, but I never use it. Is that a function, yes or no?
Yes.
Si, senor. Si, claro. -3 only goes to one place. That's -2. 0 only goes to one place. That's 7. And 4 only goes to one place. That's 1. So this is a big fat yes. Okay. How about this one? Let's go 2, 3, 4, 6. -3, -1, 3, 6. Nope. Because obviously I just did one that is.
You did. It's not good.
Okay. Is that a function or not? No. Okay, no. Because 2 goes to both -3 and to 3, right? Since that goes to 2 different places, that's no good. So that would be done. All right. So now that's only one of the ways to show the different ways to show a relation or whatever. Let's skip that, looking at it like that. Let's just look at some ordered pairs. No bueno? No te gusta? Okay?
What are you saying?
I don't know.
I don't
You don't like it? Why not?
Because the 4 and 4.
Because the 4 and the 4? Okay, so in this case, the 4 gets mapped to a -1. And in this case, the 4 gets mapped to a +1. And so we put the same number in 2 different times and got 2 different answers. And so that means no good, right? Everybody agree with that? No bueno.
Wait, so the domain can't coincide and the range?
Well, let's talk about that as soon as I answer this important question. Okay, so Lindsay asked an awesome question. This one is no good because the domain value got repeated and then the range value was different. So she wants to know, is that true like both ways around? So let's take a look at this and see if you can figure it out. So -7, 14, 9, -7, 14, 7, and 7, 14. So the question is the same. Is that a function, yes or no? Yes, it is. Is there ever a case where the same number is inputted 2 different times and our answer comes out different? No. As it turns out, in this function, there are 2 different ways to get the same answer. Is that what you were asking, Lindsay?
Yeah.
So there's a 14 here and a 14 here, but that's okay if it's the range, it can repeat itself. Okay? And if we go back to the car metaphor, if you want to make your car go forward, how many different ways can you do it? You put it in first gear, you put it in second gear, right? Okay, so there's a lot of different ways that you can get the same result, and that's okay. What's not okay is when you try to do the same thing and then something different happens each time. That's when you run into problems. All right, now here is the million-dollar question of the day. And we will know whether you really know what's going on or not if you answer this one correctly. So let's say that we have, remember there are some different ways to show relations, right? So now we looked at the mapping thing, that was pretty easy. If there's 2 arrows going down in one domain thing, it's no. We look at the ordered pairs, that's a little bit trickier. Now let's take a look at a, that's not what I wanted. Let's take a look at a graph. Okay. Function, yes or no? No. Definitely not. Why not?
Because it's going through the same numbers.
Well, I'm not really sure what you mean by that.
Definitely not.
Can somebody? Right, it has to do with the vertical numbers here. So for example, if I take the number 2, if I were to plug in 2, I wouldn't know whether I was supposed to go up here and get 5 as an answer, or whether I was supposed to go down here and get -5 as an answer. So 2 has 2 different answers, as do all of these numbers along here. And so that means that this is not a function. And so Greg, do you remember the vertical line test? Or did you just come up with the vertical idea on your own? You did an average, okay. So the easy way to look at a graph and tell whether it's a function or not is by using the vertical line test, is what we call it, these crazy math people. And what that means is if I can take a vertical line, and if I can take that and put it anywhere on this graph so that it crosses the graph twice, then it's not a function, because that means that there's 2 different output values for this one input value. Does that make sense?
Yeah.
Okay. And sometimes people also call it the pencil test, because you can just take the pencil and run it along the graph and see whether that works or not. All right, so let's take a look at some other ones, some other graphs. Clear grid. No. Clear annotations. Okay. So how about this one? Is that a function? No, because there's all kinds of places where I can draw a vertical line where it's going to cross that twice. So that is no good. How about This one. Is that one a function? Yes. What kind of function is it? We studied this together 2 years ago. Do you remember?
Hold on.
A
It has
point.
something to do with like. Can we have a hint?
Linear.
Starts with an A.
Oh,
It's
a point scored.
That's the absolute value function.
an absolute value function.
Yeah, good. Okay. All right. So you guys have got that going on pretty well then, huh? So we're good with that? All right, let me make sure that you have taught, oh, no, we need to do one more. All right, so we're going to be working a lot with functions. And functions have a fun thing called function notation. It's very good. And all function notation is we take this, y equals 3x plus 2.
I feel like it's fun.
Spelled what wrong? I did. So to take you familiar with the old-fashioned y equals 3x plus 2, right? And we're going to change that into function notation. Function notation looks like this. F of x, and the way you say that is f of x equals 3x plus 2. Same thing as y. F of x is the same thing as y. The only reason why they change it is because it makes evaluating functions easier to write. Because if I wanted to have you plug in, give me a number. If I wanted to have you plug in 7, then I would have to say y equals 3x plus 2, and then x equals 7. In function notation, the way I tell you that I want you to plug in a 7 for the x is I just say f of x equals 3x plus 2. What is f of 7? And so since I changed, it's not multiplication. These parentheses do not mean to multiply. So since I changed this x to a 7, I have to change this x to a 7 also. So that would make me go rewrite it as 3 times 7 plus 2, and then that would give me 23. Okay? And this is advanced algebra, right? So next year, when you're in math analysis or pre-calculus, then we get to do all kinds of fun things with function notation. So this is what we were doing today. In math analysis, we weren't putting numbers into functions, we were putting functions into functions. And so the whole function thing is a really vital part of math. So does everybody understand that notation, what that means and how to work with that? Okay. So if I asked you what is f of -2, what would you tell me? Plug it into the one that's already up there, yeah. Because that's the only f that's there, so and f stands for function. -4, good. Because -2 times 3 is -6, and -6 plus 2 is -4. Okay? Right?
Assignment?
Assignment.
All right.
Wow.
What time are we out of this class?
Same time as every day.
All right.